In this video, we are going to take a look at the Java compile and packaging process. And this is because Apache Maven, exactly what it does is it's going to build our Java applications, i.e. compile them and package them. So let's do a quick refresh and review of those. So let's take a look at the Java compile process. Just as a quick refresher, we are going to have source files, and those source files can be in a variety of languages. Java, of course, with the .java extension, that's going to be the primary one that we'll be working with. But Maven can also compile alternative languages such as Groovy, Scala, and Kotlin. Those are all available, and that's not a complete list. There's a number of alternative JVM languages that Maven can handle. These are probably the most popular ones. So these files are going to go through the Java compiler process, or Java-C is the executable name. And this is going to get compiled down to class files. And these class files are going to contain bytecode, platform-independent bytecode, that can be executed by the Java JVM, the Java virtual machine. So the Java virtual machine is going to take these class files, the compiled down bytecode, and run that. And the JVM is what makes Java platform independent. So it's going to take these class files that are platform independent. The JVM itself is platform dependent. So you'll have to install a specific JVM for the operating system that you're on. But the class files, compiled class files, just as a refresher, those are platform independent, meaning that your programs will be able to run on a platform that has a JVM that will be supported on it. Now, packaging, Java applications are often many, many classes, if not thousands or tens of thousands of class files are going to make up a Java application. Now, what's going to happen is we will take these files and we'll combine them into a single file using zip compression. Now, these files are commonly named .jar, .war, or .ear. And these are a zip file. And then at runtime, they are often unzipped and then executed by the JVM. Now, Java packaging, let's take a closer look at the different types of Java packaging. The most popular is going to be the Java archive file, or a jar. This is going to be a zip file containing one or more Java class files. And this is probably the simplest of them. I'm not going to get into the specifics of a jar file right now. There is a specific format that follows. We will see that later in the course. But keep in mind that the jar file is probably the most common and simplest of everything. Now, a WAR file, web application archive, is also a zip file, but this is going to contain much more. It's a little more complex than a jar file. It's going to include one or more jar files, or can include one or more jar files, all the Java class files for that specific web application, web resources, and more. So it's a complete web application intended to be deployed as a whole. And then an enterprise archive. This is a zip file containing one or more WAR files. So the enterprise archives can be quite complex and quite large, but again, this is a file that's intended to be deployed into application server, and it's all self-contained. Now, lately, we've been seeing a fat jar. Some people call it an uber jar. The terminology is a little flexible here. This is an executable jar which contains all dependencies. This is what, by default, Spring Boot is going to be using. So it's a deployable file that we can deploy out on its own. It doesn't need anything else to run. And then a trend that we've been seeing over the last couple of years is also Docker containers. So we'll take a Docker image, and that image is going to contain the runtime environment, the JVM, and a Java package. Typically, what we'll see is a fat jar inside. Typically, you can get creative and run an application server in there, but typically it's going to be a fat jar. And that is also a self-contained deployment entity. Now let's talk a little bit about deployment. Simple jar files. These are typically very targeted libraries that we can use to compose an application. So we're going to use a collection of these and compose it. Typically, this is what we're going to be doing with like a Spring application, where we're going to have multiple jar files for the libraries that we're including. Then our application, which is going to leverage those. Think about in Spring, you're going to be using like Hibernate, for example. So you have all the Hibernate dependencies, and then your application dependencies, what you've defined for your application, which is going to leverage those jar files. So these are going to be used to compose those. And again, I'm talking about simple jar files in this example. EAR and WAR files, These are typically complete applications. So the file is called a deployment artifact. And this artifact file is going to be deployed to some type of application server such as Tomcat, WebBoss, WebSphere. So a lot of the big old application servers. These are going to be existing application servers that the file is actually deployed to. So these servers have consoles and deployment tools and whatnot. So a number of tool sets around that. And this is kind of older school type stuff, more traditional Java. What we're seeing is over the last several years, FAT or Uber jars are starting to be the direction that the industry is going, where it's a complete application. There is no standalone application server, so these are deployed on their own to a server. So the key point is that it's going to be standalone. Now, often these are being put into Docker images. Again, these are complete applications which can be deployed standalone. And probably where the industry is going right now is primarily either Uber jars, FAT jars, and Docker images. We are seeing less and less emphasis put into the traditional application servers and going to more of a simplified deployment. And this is largely driven by industry trends where we're moving away from these very large monolithic applications deployed on these farms of application servers to more microservices. So the latter, the Uber jars and Docker images, you'll see that more prevalent with microservices. And this is just trends in the industry. Now, everything that we're talking about here, Maven does support, and we'll be looking at a number of examples of this in this course, but I thought it was important to get through some of the basics of what we are doing when we're building Java applications, and also to look at the different trends in the industry and get this terminology down between jar files, EAR files, Uber jars, and Docker images.